Good afternoon, ladies and gentlemen. Thank you for attending Improving's April 23rd virtual Lunch and Learn. We are thrilled to have you join us today. Before we start, I want to inform you about a feature in the presentation that will make the session more interactive. Please make note of the question mark icon at the upper right of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our insightful presenter at the appropriate time. Speaking of insightful presenters, I am proud to present John Cavnar-Johnson, who is a principal consultant at Improving. Today, John will be sharing a webinar titled .NET is not supposed to do this, is it? The floor is all yours, John.
Thanks, Sherman. So if you've ever been to one of my my presentations before, you probably will recognize a couple of slides that I'm going to start with. So the first one says, say not I have found the truth, but rather I have found a truth. And I find that to be a really important lesson for software developers to remember. There's no real big the truth in our business, but I hope to share with you a little bit of a truth that I found today. And then the other slide that you'll probably recognize if you've been to one of mine before, all models are wrong, some models are useful. And I think that's also really important to remember. What we do as software developers is really about building models of the way the world works. And we also bring a bunch of mental models to our work that really have an impact on what we do. So, it's really important to remember that, that other fella, he's not wrong. Well, he is wrong, but you're wrong too. The question is, can we find a useful thing to do out of this? And I have found that this code that I'm going to present to you today was really useful in a very narrow situation. And I had a lot of fun with it, and I hope to share a little bit of that fun with you guys today. Now, you may find yourself someday having written code that looks like that. That's pretty weird, honestly. When I ended up with this code, I wanted to ask myself, how did I end up here? What led me to write something that looks like that? And what does that even mean? So here's what we're going to talk about today. But before we talk about what we're going to talk about, I want to talk a little bit of something a little meta, which is about communication. And this is important for this particular talk for a couple of reasons. Most of us think about communication as basically the transmission of ideas, right? Transmission. There's another way to think about communication, and that's the ritual aspect of communication. So if you think about transmission, that's the movement of messages in space. We build a lot of our applications that way, at least I do. If you think about, a box score or the weather report or somebody telling you about what happened, right? That's the transmission model. But we often don't think about what I call, or actually what people call the ritual aspect of it. In the ritual aspect of communication, we're creating a shared world in which we dwell. Now, what does it mean exactly? Well, think of a few examples here. If you've ever been to a marriage ceremony, right, there's communication going on there that's really not imparting new information. Everybody knows that the bride and groom are going to say, I do. But it's an important part of a ritual that communicates something outside of the words. Same thing for a religious ritual, a sermon that you might hear, or a political speech. Think about going to a rally, say, for Bernie Sanders, and he says he's in favor of Medicare for all. That's not news to anybody. Everybody knows Bernie's in favor of Medicare for all, right? When he says that, right, there's a big reaction. Everybody in the crowd cheers. And that's what I mean about creating a shared world. It's a reminder of what's important. And now, everybody out there is probably thinking, like, what does this have to do with your presentation about that weird code? So let me explain that. So this presentation is a presentation of what I call clever code. Clever code is a kind of code that I generally try to avoid because it's dangerous. We'll talk a little bit later about that maybe. The problem with clever code is when you present clever code, it's very easy to think that the ritual aspect of this is what somebody calls hacker culture, right? Where you're showing how clever you are. I'm really not here to show you how clever I am, because I'm pretty sure that there are people in the audience who are way clever at coding, more clever than me at coding. Though what I want to do is talk about meeting the needs of our users, our customers, the people we're working for. There's no value to me in clever code unless it accomplishes something that our users need. So I want to set the context for the code I'm going to present and talk about what the need that I'm trying to meet is here. So I want to allow F# developers to use Martin in an idiomatic way. So F# is a .NET programming language, and that's not the most popular .NET programming language. C# is, and Martin is an event sourcing. Well, actually, it's a document database and an event sourcing tool that uses Postgres as its backing store. But I'm only going to really talk about the event store part of it, and talk about event sourcing. I just want to say right now that at the end of the presentation, I've given Sherman, the moderator, a bunch of links. So if you want to find out more about Martin or some of the things I talk about, there will be links at the end. I could have had him put them in there early, but then people would just go off, no, I'm teasing. So this all started, like a lot of things start, with a GitHub issue. So, and I want to say right up front, this is something I did in my spare time, not in my work time. This is not something I did for a client of improving or anything like this. This is, I was looking around at things. I actually, on my own time, was investigating Martin because I like event sourcing, and I was looking for something better than the hacky way that I've done it in the past. And I really liked Martin, but I noticed that there was an issue with F#. There's a problem using F# discriminated unions in Martin. We'll get into exactly what the problem is as we go along. The thing you need to know is under the covers of DIL, DUs are abstract classes, and their cases are concrete classes. Don't worry about that right now. We'll show you some code in just a minute, and you'll understand what that's all about. Now, Martin needs a concrete class for an event, which, because Martin is written in C#, it makes perfect sense. It really does. It's just kind of obvious from a C# perspective, is that's what you would expect, because it's going to use that as it helps you do projections and aggregates and things like that. But the idiomatic way to do event sourcing in F#, in my opinion, and apparently the opinion of other people who use Martin and F#, is that you would typically have a discriminated union that would represent your events. So let's start looking at some code. Okay, so everybody should be able to see the screen, right? Just nod and pretend I can see you. So I want to go, and the first thing I want to do is walk through the problem. So we'll start over here. Our scenario here, and this is, I picked this up pretty much straight from the GitHub issue, is as an F# developer, you typically create some types. So this one is, imagine we're creating a bank account. So you'll create this type that's a record. Hey, you guys have records in C# now if you're a C# developer. So, hey, actually, let's see if Sherman's paying attention. Sherman, ask everybody to put in the chat what their primary development language is. So it might be F# or C# or JavaScript or something like that. And then at some point I'll ask and see what the results were, just at a high level, half and half, 50-50, whatever, right? Okay, so we have this account creation time. We have a transaction, right, where we're going to move money from one account to another, which will be represented by unique identifiers, right? And they have a, there's a description, sort of, like the line you'd have on a check. Anybody out there remember checks? Anyway, the time that it happens and an amount, which is a decimal, right? Now, this is the part that is of interest. Now, for the non-F# developers, this is a discriminated union. And this says, okay, this is a type, and it can have these different cases. It might be an account created event, which the type would be account creation. It could be an account credited, which would be a transaction, or an account debited, which would be a transaction, right? And typically, now, the way Martin works is it typically expects you to have an apply method that takes your event class and does your thing. So an account can be considered a projection or an aggregate. We'll get to that in a minute. But you'll have this account and you have this apply event, which would take your discriminated union. It would match on the discriminated union and go do something, probably more than what I'm doing here. But typically apply events will not return anything, which we call that unit in F#. If you're from the C languages, you probably call it void, whatever. There's no return, right? And so if you get a credit, you go create the account, and a debit would take money from one account to the other, as would a credit, right? Depending on your perspective. If you took accounting, you could probably remember which one's which. It's been way too long since I took any accounting. Anyway, this is a fairly typical setup where you have a discriminated union and an aggregate that applies the events as they come in. And the way you typically would use Martin is it would look something like this. So you would have this, you're going to set up your document store, which you have a connection string, right? You create a connection. Now, this is an interesting line right here. This one right here is actually really important. We want to talk about that one a little bit later, but it's not a requirement in Martin, but it's useful and helpful to be able to add your event type. And you do that by passing typeof. Now, typeof works in F# just like it does in C#, right? You give it a system type and it passes the type as the parameter, right? And then you tell Martin what your projection is. And this is called a self-aggregate in Martin terms, which just means that it will handle events as they come in. And once your stream has events, you can project them into this aggregate. I hope those terms are relatively familiar to people. If you've done any event sourcing, they probably should be. If you have questions on those, in a minute here, I'll stop and we'll ask questions. So if there's something that I've assumed that you know that you don't know, feel free to ask and we'll handle those. So don't worry about this. This is just creating identifiers for two people who are going to have accounts. By the way, I generally use, instead of making up my own fake names, I use superhero names. So you'll have to go look up those people. I'm not going to give you the links for those, but we have two people, Fadi and Elena. And we're going to create an account, right? So we have an event for creating an account for Fadi. We set the owner, the account ID, the starting balance, and when it was created. We do the same thing for Elena. Elena's starting with no money. I don't know what bank lets you start an account with no money, but okay. And then we have a transaction where it's we're crediting an account. So it's a type transaction. And it's going from Fadi to Elena, and it's 100. Oh, by the way, the M, if you're wondering, that's how you specify a decimal in F#. So that's a decimal of 100. the time is now, right? And we have the description, right? And now this is where we start using the Martin infrastructure here. So for this session, we're going to append an event to a stream of events. The ID specifies it's for Elena, and this is an account event that's a transaction, right? And then we're going to create, now, a sequence in F# is effectively an IEnumerable. So this would probably be creating a list if you were doing this in C#, but we're going to say there's one event that is the creation, and then there's the one event that is the transaction. And we're going to append those events, and you'll see why I did this two different ways in a minute, but we're going to append those events to the stream for Fadi. So now we have two event streams going on here, one for Elena, one for Fadi. If we were really running a bank, we'd want this all to balance out, but we're not going to worry about that right now. Okay, so then we're going to save the changes, which gives us a task. And this is typically what you'll see in F# code for something like this. You will use an async to await the task, and then we will run synchronously. And I'm not going to go into all the differences between the way asynchronous things work in F# and C#. That's a whole other presentation. But eventually, this just saves the changes. And then we're going to create an account. And we do that by calling load async. And we give it the ID for Fadi. And we do the whole running it asynchronous or running it synchronously. And then we're going to, so by the way, this is a nice little bit of feature for VS Code is it shows you what's happening on each line, what the result of each line is. So this isn't going to end up being an account, right? And then we're also going to get the streams for Fadi, the stream of events for Fadi. And the reason we're doing this is simply because originally this was a piece of demo code for a bug report, right? And what would happen is if the code ran the way it is now, it would not work. The reason it wouldn't work is that if you remember over here, that DU was an abstract, remember I described it, it's an abstract class and the cases are concrete. Well, Martin is expecting a concrete class. And so it breaks. Now, there's a way around this. You could not use a discriminated union. That really does not sit well with me after having had some experience with F#. It is very much the way you intend to do things in F#. So the other thing you can do is to wrap that discriminated union in a record, which is actually a concrete class, and then unwrap it on your way out. Perfectly fine solution. It's just tedious. And, when I deal with tedious code, my first reaction is like, maybe there's a way I can automate this because, I'm a software developer. I'm lazy. I really don't want to write that kind of code the same way every time, because if you do something the same way every time, that's something you want to get the computer to do, right? That makes sense to everybody. So that's the problem. That's the context. What I want to do here is I want to solve this problem without making any changes to the code you've seen so far. That is, I want the system to work the way you wrote your code as a good F# developer. And the only way I can do that is to change the meaning of your code and make it do what you want it to do rather than what you ask it to do, if that makes any sense. So I'm going to stop right here for a minute and ask Sherman if we've got any questions.
No questions so far, but we did have some people state that they're using C# and Java as their programming language of choice.
Okay, that gives me a little bit of background for what I need to talk about. So I'm glad there are no questions so far. Now this is where things get weird. So the one thing I'm not going to do today is I'm not going to show you the code that actually does the generation. The reason I'm not going to do that is it's complex, it's tedious, and again, that's really another presentation. I'm just going to ask you to trust me that I can actually generate the code I'm going to show you here in a minute. And so let me explain how the solution that I came up with works. So at compile time, you add a step to your compilation process that says, from this list of files, hand them to this command line utility that I'm going to call Martinizer, with much apologies to the folks who do that, name for the laundry, but it seemed better than my alternatives. If anybody has other suggestions for name, let me know. But what that does is it goes through and it parses the abstract syntax tree. For some reason, I have trouble saying that word. It parses the abstract syntax tree. It looks for discriminated unions, and it looks for types that have an apply method that have a parameter that is one of the discriminated unions that it found. So think about this logically. I'm going to go through and I'm going to find this, and I'm going to find this. And so what I know I want to do is I want to create a system that does the wrapping and unwrapping of these events automatically. And it doesn't make you change your code, it just adds some code. Which sounds kind of like magic to me, because I'm about to go and the code you wrote is going to not quite do what you ask it to do, but it's going to do what you want it to do. So we need to, at this point, kind of step back and take stock of what are our tools that we can use from F# that would allow us to do this. Okay, hold on just a second. Oh, there we go. Okay, so get rid of that. So we're going to use optional type extensions. Optional type extensions are actually fascinating. In C#, if you're familiar with C#, you have extension methods. F# has those too. This is not them. Optional type extensions are interesting because you get to add them to somebody else's code. So they're outside of the module or namespace or assembly of the type that you're extending. So you can add functionality and tack it directly onto an instance of somebody else's code. And this is going to be really important because it's going to allow us to do some useful sort of trickery. So it's, we get to extend a type that we didn't define. Now, this is the part that really gets interesting. You can overload methods of that type that have the same name as long as you're careful to allow the compiler to distinguish between your method and the method that exists on the original type. So what do I mean by that? So you can write what is effectively an overloaded method as long as you can figure out a way to make the parameters of that method be different than the ones of the original type. Now, the important thing you remember is these are only available to F# code, like C# and VB can't see these methods at all, no matter what. No matter what you do, you can only see them from F#. So anything we do like that has to be done on the F# side of the code. The other thing we're going to use are statically resolved type parameters. Now, I'm going to be honest. This is one of those features of F# that the first time I saw it, I was like, I'm never going to use that. Just never going to use it. They're generic type parameters, but they get replaced with an actual type at compile time, not at runtime, like you would expect normal generics in .NET that you have in C# and VB and F#. That means they're inline. Everywhere they get referenced, they get replaced. So we'll see what that means in a minute. So you know what? Time to go back to some code. So let's start looking at the code that my application generates. So we're going to scroll over. When you originally start out, all that is in the generated.fs file is the declaration of the module. So the generator opens up the Martin namespaces that it needs. By the way, this is the same thing as a using in C#. Can't remember, it's been too long since I did Java, but there's a way to do the same thing in Java. And then it opens the namespace in the file that you handed it. So remember, we're going to hand it this file. So its namespace is account. So we're going to open that. The first thing we're going to do is create this wrapper. So just conventionally, I'll name this wrapped and the name of your type. And it's a record that has one field, right? And by convention, I call that enter. And so you can unwrap this wrapped event, get at the enter value, and then you can use that. So I add to your existing type, this is the optional extension, a new apply. And this apply takes a wrapped account of it, unwraps it, and then calls your original wrapped, your original apply, excuse me. So let's stop right there for a minute, because this is important, right? So I'm just adding a function, some functionality that unwraps the thing and calls the code that you already wrote. So if I can figure out how to make this all work, right, it will be transparent to you because your apply event's going to get called exactly the way you intended it with your discriminated union. This is all happening on the F# side, so there's no problem. Now, that means we have to do a lot of other stuff. And I'm not actually going to show you everything. I'm going to show you enough so that you get the idea of what I ended up doing. So this is the I event store for Martin. It has a whole bunch of members, very fun, you know, it's got a lot of functionality. And what we want to do is we're going to write new append methods. And our append methods take your discriminated union, we're wrapping it up, and we're appending that, right? So we've intercepted the append, done the right thing, and then call the functionality that's already built into Martin because it does a lot of stuff, right? Well, append doesn't take just a single method, it also takes a sequence, the IEnumerable, basically. So we need to do that too. And now this gets kind of fun. So we take the sequence and we map that. And this is my favorite thing about F#. Fun is a key word. Anytime you use lambdas, anonymous functions, you say you're having fun, which I think is cool, but that's just me. So this works more or less the way you'd expect an anonymous function to work if you're coming from C#. We create a record, and because we're calling this iter and we're setting its value from something that is an account of it, it knows what to do. Now, here's the really interesting thing. This little operator right here why would we turn this into an object? So what we're going to end up here, like if you hover over this guy, right? Oops, why is it on left? Oh, I'll hover over down here, maybe. Ooh, that's fun. Okay, so this is actually now going to be a sequence of objects. And the reason we do that is we want to make sure that we call that, that's the way the append method is defined, is any sort of IEnumerable. So that's what we need to do. Because in F#, you really have to make your types work right. You have to match this stuff up. And then we also have an array. So this is another one of the versions of append that we need to wrap. And so for that one, we do basically the same thing, except we're using array.map. And turning it into a sequence, then we end up actually calling the same function that we're calling up there. The whole point of this is that we have to think about every possible way you could be appending your account events and make sure that we intercept all of them and send it to Martin. Because what we do, see, this is actually applying this to some instance. So here's the tricky part about optional extension methods, or excuse me, yeah, optional type extensions, not extension methods, optional type extensions. They get created as a static method on an instance of a type, but they have the appearance of static or instance based on how you define them. So that doesn't make a whole lot of sense. So in the links that we're going to put in the chat, you'll have a link to the documentation that explains this. I had to read it a couple of times to really understand. But basically what this says is, like, if anywhere in your F# code after this, you have any sort of instance that is of I event store, and you call it with an account event, it will actually invoke this code. So again, this is just a way of intercepting the calls and making sure that it does what you want it to do. So there's actually a few other things we add to an I event store, but we're not going to talk about those right now. And then for iDocument session, basically I only define the ones to make the rest of the code work. So I can kind of walk through at the end. I'm going to walk through what this actually ends up doing. So we describe our own load async. So this says, okay, this is a generic parameter, and we're using when that is an account. So if you call load async with an account, passing it in good, we're going to do this. And what this does is it creates an async. Ooh, I left a comment in there. It basically does exactly what load async does in the code for Martin. Like, this would not be very easy to do if Martin wasn't open source, but it goes through and it actually loads wrapped account events. So it knows that instead of sending account events, we've sent wrapped account events to Martin. So we need to take those and call the apply method on the account. And then we start it as a task because this thing returns a task. So again, all we're really doing here is when you call it on account, because we know that account had an apply method that took an account event, we're going to intercept that call, do the right thing, let Martin do as much as we can, but then, because you'll notice we're calling Martin's code here. So that'll handle load async. There's a bunch of other things we would need to do and generate if this was the actual code that I'm going to be releasing. But that's enough to explain what happens. And now we get to this part. So here's what's happening here. Now, this inline says you're going to have to integrate this directly. Anytime you call this function, we're going to replace the call to typeof to this call. Now, the trick on this is typeof takes a system.type. We need something that's more generic than system.type because, again, what we're doing is intercepting some code. So we define it as system.object. So this just says, okay, if you call typeof with a system.object, which nobody's ever going to do that, right? Because you're always going to call it with a system.type. Well, we're going to check your type of whatever you passed in. And if it's equal to the type of an account event, we're going to make typeof return a wrapped account event. And if it's anything else, we're just going to return the type of the thing you passed in. Think about that for a minute. Now, let's walk through the program code and show you what happens. So if I hover over typeof right here, you should be able to see that it is coming from Microsoft.f#.core.operators.typeof. Right? Now, if I uncomment this line, give it a minute for everything to catch up. And now, this call to typeof calls my code. And it does the thing I wanted it to do without you changing any of your code at all. Because in fact, the way this works in the real world is you already have the open Martinizer in your code at the beginning. There's just nothing in that module until compile time when we write all that code. Now you go down here, right? All this, everything works the way it's supposed to. Everything is fine. And we get down to append. And now you'll notice that append is calling my append because you're passing it an account of it, right? Same thing here. Because you define this as an account of it, and F# is very picky about these sorts of things, if and only if this is actually a sequence of account events, it'll call the code that I wrote. Makes sense so far, I hope. Then you save the changes, which is just, that's standard old, Martin code. But this guy is now my code. And it calls the load async method that I wrote. Now, we didn't have to change fetch stream, so it's still the Martin code, right? But what happens when you get down here is now you actually get an account that apply to all the account events. So let me go back through that real quick. So when you tell it that you're going to send account events, we actually say, no, we're going to send wrapped account events. And when you append these events, you're appending account events, but what actually gets appended in Martin is a wrapped account event. And then when you load this projection up, this aggregate, it's going to call our code, which is going to take the event stream, unwrap the events, call your replies, let that all, make the infrastructure work where we're just adding the unwrapping. So this is a good time to pause and see if we have any questions.
We don't have any questions right now.
We don't have any questions. Okay, so I want to ask a question so people can reply in the chat. Do you not have any questions because I explained it well, or because you're totally confused. Because those are the two primary reasons people don't have questions. So if somebody wants to, to answer that question, that'd be great. So in the meantime, there's a couple of things that I want to point out about this sort of solution. When I initially looked at this issue, I was like, we got to fix this. Event sourcing is a very popular thing in the F# community. Now, granted, the F# community is not that big compared to the C# community. I get that. Martin, Jerry Miller, who's the founder of that open source project, is pretty considerate of F# developers. But let's face it, we're not the majority of his users. So I figured, look, somebody from the F# community should try to, take a swing at this and see how to fix it. And it's not an easy thing to fix. I mean, sure, I could work around it in my own code with a lot less trouble than this. On the other hand, this is something that we really, I want this to be something that we can, that will just work for people. And it's a little complicated, I'll be honest. Part of the complication is Martin's about to release a new version, 4.0, and a bunch of stuff changed. So I'm writing this to support 4.0, not the current 3. whatever. But the 4.0 should be out very shortly. And so as soon as it's out, I'm going to tidy up my code and release it in an open source fashion so people can take a look at that. And if you're really interested in the crazy code generation stuff, I will say this, that code is some old code that I had. It's a bunch of stuff that I borrowed from a project called Myriad, which is really cool. You should really check that one out if you're an F# developer. So I've got something old, I've got something I borrowed, I've got, the new code that I wrote. If I got something from IBM, I can marry it. That's a joke. Somebody's going to get that in about 5 minutes. Anyway. So, Sherman, has anybody had enough, guts to answer the question of, are they totally confused?
I didn't get a reply, so I guess everybody's
so
good.
We're just going to assume that everybody's totally confused. I think that's the safest assumption to make here. So that's really the end of the presentation. I finished up a few minutes early. You get 15 minutes of your life back because nobody could come up with a good question. Sometimes when I do this, I make up questions so that Sherman has something to ask and he doesn't feel embarrassed about there's no questions, John. But I figured this one is confusing enough that, if you have questions, you'll ask your questions. If you don't have any questions, that's okay too. So Sherman, do you have some stuff you need to do at the end?
I'm going to post the links that you shared.
Excellent.
I'm going to send those right now to everybody. And then I'm going to take us away. Okay,
so I hope everybody had at least half as much fun as seeing this as I had writing it, because it was actually a blast. I saw a quote sometime from somebody. It's like, how do developers who are over 30, stay engaged in software development? And I thought, well, gee, I'm twice that. But I stay engaged by doing fun stuff in my free time. So this was a fun thing I did, and I wanted to share it with folks. So thank you very much.
Thanks, John. Thank you all for attending today's virtual lunch and learn. And John, thank you for sharing. .NET is not supposed to do that, is it? The recording of this session will be available the next business day. To view the recording, locate the session from Improving's virtual events page. As a reminder, all of our virtual lunch and learns are recorded and shared for your convenience. Thank you and have a nice weekend.